So in this question, we're asked to consider this mixing tank here, where we've got fluid going in pipe A, and we know the volumetric flow rate and the density of this fluid, also the diameter of the pipe, and we also know the same parameters for pipe B going in. And we've been asked to find everything that's going on in D, so the mass flow rate, the velocity, and the density of the mixture. So basically we need to use the continuity equation to solve this. So we know from continuity that the sum of the all the masses going in, mass flow rates going in, has got to equal the sum of the mass flow rates going out. So we've got pipe A and B going in, pipe D coming out. So therefore the density times the area times the velocity for each pipe has got to, if you sum those two up, has got to equal what's coming out. And if we remember our flow rate relationships, we know that the area times the velocity is the volumetric flow rate. So the density times the volumetric flow rate is equal to the mass flow rate. And we're given those two in the question. We're given the density and the volumetric flow rate. So if we plug those into our calculator and add them together, we get the mass flow rate at D as 112 kilograms per second. So it's the density times the volumetric flow rate for each pipe going in. Now we can also show that because we've got incompressible flow, that the volumetric flow rate, the sum of the volumetric flow rate in is also equal to the sum of the volumetric flow rate going out. So every time we put a bit of volume in, that volume has to come out if it's incompressible. So again, we can get this relationship. There's a volumetric flow rate going in plus the volumetric at B is equal to the volumetric coming out in D. We know what's going in, so we can work out what's coming out. Okay, and we know that the volumetric flow rate that's coming out is equal to the area times the velocity in the pipe. And we know the area of the pipe because we're given its diameter. So if we work out the area of that pipe, divide the volumetric flow rate by that, we get the velocity in pipe D, which is 6.79 meters per second. So finally, we know the mass flow rate, we know the area, and we also know the velocity, so we can find the density from this equation for the mass flow rate. So if we rearrange this, we get that the density is equal to the mass flow rate divided by the area times the velocity, and we've worked that out previously. So we plug in all the values and we get an answer of 933 kilograms per meter cubed.